A ratio is the quotient of two quantities, or you could say two measurements that are put together through division, or usually as a fraction. For instance, speed. It's distance over time, or distance divided by time, or we could say in terms of a ratio, the ratio of distance to time. Something else from the driving realm, pressure, as far as the pressure that you have in your tires, happens to be a ratio as well, the ratio of weight to area, the weight that is applied and the area that's in contact with the road. Something else that you might be familiar with that's not actually presented here on the screen, be a ratio when you're grocery shopping. The unit price, how much money per ounce or per pound or per whatever we might have, box of something, bag of something else. So that sort of thing, also an example of a ratio. As it happens, these are also examples of what we call rates. The word rate is used as a distinction. This is going to be a very particular kind of ratio where we're dealing with different kinds of measurements. So they have to be different kinds. So for the sports fans, whether you're talking about basketball or football, you can have this ratio that shows up in your stats. For instance, the number of completed passes to the number of attempted passes. You're counting the same sort of thing. So these aren't really two different kinds of measurements. So it would be a ratio, but not a rate. And again, just to bring up something else from the driving realm, since we're most familiar with that, the number of miles traveled to the number of gallons used. Two completely different kinds of measurements, miles versus gallons, completely different. So this would be not only a ratio, but also a rate. In order to actually do something useful with these, other than, for instance, the grocery example, what we need to have going on are what we call proportions, an equation that has two ratios in it. For instance, a little something that we're familiar with and a little reasoning behind what we know that uses some information from back when we were dealing with fractions. We can look at any fraction as a ratio. And so we know, for instance, that 1/2 is the same as 4/8. So 4/8 is just not a reduced version of that fraction. But we know that they are equal. Now, other than knowing they're equal because we can do a little reducing and change the 4/8 to a 1/2, we also have a little something else that we can use that'll be a lot more helpful when we've got less nice numbers to work with. And that's this idea of cross multiplying. We use this when we were comparing fractions. Other than being able to compare fractions, which one's bigger, which one's smaller, we can also say, are they fractions that are equal? So these fractions are equal if I do the cross multiplying and I get the same thing for each of those cross products. So this allows us to do some useful things eventually. Let's look at an example first where we use this cross multiplying. X over 9 equals 5/4. So we don't know what x is. In order to find this out, because we can view x over 9 as a ratio, we could view 5/4 as a ratio. So this equation, we can view it as a proportion, and we can solve proportions by starting with cross multiplying. We got to do a little something else, and you'll see that in just a minute here. Let's again emphasize the cross multiplying by referring to doing x times 4. And a little side note here, remember that we always have to start with the top of our first fraction, just to make sure that we're getting everything worked out and in good shape. The other part of our cross shape would be the bottom of our first fraction times the top of our second fraction, and these are supposed to be equal to one another. The way that we would more normally see something like the left-hand side, though, is to have the 4 first, followed by the x, and we normally wouldn't see the multiplication dot in between them. We would leave that off. And on the right-hand side, we can actually work out 9 times 5 is 45. Now, we don't have the x completely by itself, but it's almost there. If we could just move this 4 out of our way, then we would be able to have the x by itself. We would know what number should have been up on the top of that ratio. Well, in order to move that 4, I need to disconnect it. We just said that the way that they're connected is literally through multiplying. The opposite of multiplying is dividing. So to undo multiplication, we'll do division. The thing that I want to move is the 4, so we're going to divide by 4. Now we don't want to just divide by 4 on the left-hand side. And again, let's call attention to this, dividing by 4. We don't just want to do this on the left-hand side. The equals symbol in here means that we need to keep things equal, the same, or we could say we need to keep things balanced. So by making a change over here on the left side of my equal sign, divide by 4, I'm going to need to do the same thing over on the right side. So I'm going to take the 45 I originally had, and I'm going to need to divide that by 4 as well. So this will give us our x all by itself. And when we look at this original answer that we're getting, we have a fraction. It is fully reduced. If we don't have any directions to tell us one way or the other, we could just go ahead and leave that alone and move along. But there is that possibility that we could transform that fraction into a mixed number, like we've discussed before. So turning this into a mixed number by doing the division and taking our quotient and our remainder and putting them together, we would get 11 and 1 over 4. And we've also talked about how we can convert between fractions and decimals. And this one also happens to be something we can take the mixed number and transform it into a decimal answer rather quickly. 11 and 1 over 4, 11 and 1/4, 11 and 1/4. Well, 11 and 1/4 as a decimal. Thinking money and banging that out. Easy peasy lemon squeezy. Now, that's one example. We could have different kinds of numbers that show up. So, as another example here to work out, we consider this next problem that has decimal numbers that appear in it. So again, we're starting out with the same basic set of steps. What we're going to have to do is a little bit of cross multiplying, and eventually we're going to have to do a little division, and then we should come up with our answer. So if we start out with our cross multiplying, we start with the top number of our first fraction times the bottom number of our second fraction. And that's going to need to be equal to the bottom number of our first fraction times the top number of our second fraction. Just to go ahead and clean up that right-hand side, the 0.9 times the 4.8, we're going to have a 4.32 for that. Now this puts us in the position where we have to do our division work. So we would need to take the left-hand side. We would want to get rid of the 0.4 using division. And that means that we're going to be forced to take the right-hand side and also do that division by the 0.4. So we would want to go ahead and work something like that out, and just to go ahead and really quickly run through a reminder of that. Since we have a decimal out to the side, we want to take both decimal points and slide, so that out front we will create the whole number 4, and underneath we will create the decimal number 43.2. Then the other part of our division, since we have a decimal in the house, we want to raise the roof. So we're going to go ahead and punch that decimal point straight up so that it sits on top of our long division symbol. And now that our decimal's in place, we can go ahead and work through the division like we normally would and just ignore that the decimal point's even there until we're done. So 4 goes into 4 one time. We got a 3. Well, 4 goes into 3 0 times. Go ahead and drop that 2 down. 4 goes into 32 8 times. And we get a remainder of 0. So what we have showing up here at the very end, t is equal to, well, the result of our division work here is the 10.8. All well and good, but not necessarily super awesome until we actually bring this idea into the word problems that would involve ratios. So again, we could have ratios like the ones that we mentioned earlier: unit price, speed, pressure, miles per gallon, or fuel efficiency, or anything else that might be presented in a problem. To do something that is at least somewhat familiar to us, let's go ahead and consider this particular example here where we have something that we can actually get behind, we can understand without being too awfully crazy. We've got a car that averages 450 miles on a 12-gallon tank. We want to know how many gallons are used if we take a 2,000-mile road trip. One of the nice things about these ratio problems is usually either the first half of our first sentence or the entire first sentence itself is going to give us the two measurements that are involved in our ratio. They're not going to necessarily give us the ratio to begin with. So we might have to come up with the ratio ourselves based on the first sentence, either the whole thing or like half of it. So that entire first sentence actually does mention two specific measurements. It mentions first miles, so conveniently we can just put miles on top. And then second, it mentions gallons, so we can put gallons on the bottom of our ratio. Now that's the ratio that we're going to use. That was just what we decided to do. When we build our equation, both ratios have to be built the exact same way. Miles go on top, gallons go on the bottom. So again, going back to that first sentence and picking out the specific numbers, we have 450 miles, so that goes on top. We have 12 gallons, that's going to go on the bottom. Now that takes care of only one ratio. We need a second ratio, so we need something else that's going to have a top and a bottom. We read through the second sentence, the question that they ask, how many gallons are used on a 2,000-mile road trip? So the other piece of information that they're specifically giving us is the number of miles, which we said goes on the top. That's how we are building that ratio, miles on top. So 2,000 goes on top, and we don't know the number of gallons. So that we don't forget what we're dealing with, I recommend that we use something to remind us that we're going to be looking for the number of gallons. So let's use G. Now we have a proportion equation that we can begin solving by first doing cross multiplication and then eventually working a little division out in order to get our answer. So, cross multiplying means, again, the numerator of our first fraction times the denominator of our second fraction is equal to the denominator of our first fraction times the numerator of our second fraction. And we can work out the 12 times the 2,000 to give us 24,000. And now is where we need to do our little bit of division work here. We're going to need to get rid of the 450 so that the g can be by itself. That means we'll need to divide by 450 on both the left and right hand sides of our equation. So what we're looking at here for the moment is that g is coming from this fraction, 24,000 over 450. Just to mention a few things that we can do with that might be worth noting. You may have already noticed some of these sorts of things in the past. Really quick, what we've got on the top is a number that ends in a 0, and at the bottom a number that ends in a 0. So we can go ahead and chop those right off and have a slightly more manageable division problem that is 2,400 over 45. Then you might say, well, the top number ends in a 0, bottom number ends in a 5, so 5 will go into both of those, and I can reduce that a little bit more so that we would have the 2,400 divided by 5 giving us 480, and the 45 divided by 5 giving us a 9. Then you might say to yourself, well, wait a minute, I know 48, and 48 is divisible by 3, so that you would come up with 160 on the top. 9 divided by 3 give me a 3 on the bottom. Any of these could be worked out. You just do the division in order to get your answer. The issue is that one way or another we have to work out the division because the number of gallons realistically is not presented as a fraction. Realistically, go to the gas pump, you have some sort of decimal that's being given. So if you go through the trouble of working out the division, let's use that set of smallest numbers that we came up with, 160 divided by 3, just in case we need our decimal point and maybe one extra decimal place. We'll see if we need it or not, but we can go ahead and put it in there just to be prepared. That decimal, go ahead and raise the roof, and then go get started on the division process to see how things turn out. 3 goes into 1, nope. 3 goes into 16, yes. 3 goes into 16 5 times. Do a little subtracting there, get a remainder of 1, drop down a 0. 3 goes into 10 3 times. Get a remainder of 1, drop down my extra 0. 3 goes into 10. We just said 3 times. So what we seem to have going on here is going to be a repeating decimal where it's the 3 that ends up repeating. Now realistically, even this isn't good enough because that's not the kind of decimal that they show you on a gas pump. What they're going to show you on a gas pump is going to be a rounded version. Gas pumps display 3 decimal places. So the rounded answer that we would want to have the most realistic possible answer is going to be 53.3. Repeat that, 3. Repeat that, 3. Now I have enough decimal places to have a realistic answer. And so, to be perfectly clear, for this road trip, the car uses about 53.333 G is for gallons. The kinds of problems that you would have to deal with, you would want to try to handle in much the same way. Based on what you see, figure out the ratio that you want to use. Once you've figured out the ratio that you would personally like to use, you need to build two different ratios in that fashion. Somewhere in that 4 set of information, top, and bottom, there's going to be something unknown. So you'll get at least enough information to figure out 3 pieces, and then you've got that 4th piece as your unknown. Once all that's set up, you can work through your cross multiplying, do your division, work out your answer. Sometimes that might require some longer division to work through. Sometimes it might be shorter. Follow your directions as far as what kind of answer to provide. And if they don't give you any directions, try to make it as realistic as possible, like we did here in this particular example.